Today we're going to do 44A, and pay close attention. What we're doing today is not difficult, but sometimes weird things happen. Yeah. So let's say I had the square root of x is equal to 5. What number makes that true? The square root of what number is 25? Oops, is 5. 25 is 5. Do I need to worry about plus or minus? No. When do we worry about plus or minus? When you have x squared equals 25. And then when you take the square root of an x squared, you have to worry about plus or minus. Okay? So obviously the answer here is 25. Well, let me change it just a little bit. What if I had the square root of x minus 1 equals 5? So now the number I'm looking for needs to be subtracted by 1 and then take the square root, and the answer still has to be 5. So the number we're looking for is 26. And as we continue to make these problems more and more difficult, we'll start to realize we need an algebraic way to solve this. So let's go through order of operations just like we did before. Looking at the x, what is the first operation that hits the x? Subtract 1, and the second operation is the square root. Now we pedal backwards. What's the opposite of a square root? Squared. So I'm going to square both sides, and the square root and the squared cancel. I'm left with x minus 1 equals 25. Do I need plus or minus? No. When you go the other way, if you start with x squared, then you need plus or minus. And next, I add 1, and I get x equals 26. Okay. Let's do one that's a little bit more complicated. Let's do... What should I do first? Square both sides. 2x minus 4 equals 36. Add 4. 2x equals 40. Divide by 2, and I get x equals 20. Easy enough, right? Okay, watch this. What happens when I plug 26 back in there? 26 minus 1 is 25, and the square root of 25 is 5, so I got the right answer. Okay. Watch what happens when I plug this in. 2 times 20 is 40. 40 minus 4 is 36, and the square root of 36 is 6. What did I do wrong? Did we forget an I? No. Do we need plus or minus? No. So what were you saying, Katie? So the problem we ran into was this. The square root of 36 is not equal to negative 6. And it's not a plus or minus issue. It's not an I issue. So it has something to do with the fact that I squared the negative 6. But that's not illegal. Anybody see what's happening here? Okay, let me simplify it down a little bit. What if I just had the square root of x equals negative 6? X would have to be... What value satisfies that? There isn't one. Right? If I tried 36 and I square root it, what will I get? 6. That didn't work. What if I tried negative 36? Then you get 6i. Still doesn't work. You could move the negative to the other side, but then you're going to run into the opposite problem. The opposite of the square root of x equals 6. This is just a situation with no answer. And it has to do with the makeup of square roots. When you square root a number, what sort of answer do you get? Positive or an I or 0, right? What I'm saying is the square root of x yields an answer that must be greater than or equal to 0 or imaginary, right? This answer must be positive or 0. So the square root of x must be greater than or equal to 0. There is no way to square root a number and end up with a negative. It just can't happen. You can get imaginary numbers, which we won't deal with today. You can also get 0 if you square root 0, or you can get a positive number. So there is no square root that will yield a negative number. How do we know? Let's go back. Maybe. I'll get there. There we go. How do we look at an answer and decide this is going to work or this is not going to work? You could plug it in, and that will always work. If you're unsure, plug it in. And whenever you're dealing with a square root of a variable, it's a good idea to plug your answer in just to see if it works. But we're smart. I can look back at the original problem and say the one on the left has an answer and the one on the right does not. The square root equals a negative number on that right side. So, maybe I shouldn't do that. Let's go back. Oh, it had the same effect. So if I had 2 times the square root of x minus 1 equals 12, will that have an answer? Yeah. Let's figure out what it is. Square root of x minus 1 equals 6. Square both sides. Add 1. And I get x equals 37. Easy enough, right? Okay. What about the square root of x plus 4 equals negative 3? Whatever I wrote. Minus 4. Does that have a solution? No. And right off the bat, we should say no solution. Okay. What if I had you got to be careful here. It looks like in its current state there's not going to be a solution. But is it possible to square root a number, subtract 4, and end up with a negative number? Yes, as long as the negative number on the right side is closer to 0 than negative 4. So we need to apply that idea of square roots cannot equal a negative when the square roots have been isolated. Add 4, and then you get the square root of 2x minus 6 equals 2, and then we can solve it. Do you want to see me solve this, or you guys know how you can get that? Okay. All right. What about this? Oops, that's supposed to be a plus. Does that have an answer? Yes, why? We'll subtract 9 and I get negative 6. Divide by negative 3 and it equals 2. Then you square both sides and subtract 1. We good with that? Okay. What if I had this? The cubed root of x minus 1 equals negative 3. Does this have a solution? Yes, but it equals a negative. Cubed root involves 3 copies of your multiplication. Can a number times itself equal a negative number? Yes. So with cubed roots, there are no i's because you can have a negative inside. But also, if it's outside like this, then you don't have to worry about square rooting a negative. So we would raise it to the third, and I would get x minus 1 equals negative 27, and then add 1, negative 26. Now, sometimes in the book, instead of cubed root, it will look like this. That is a cubed root. So the square root is the same as the 1/2 exponent. The cubed root is the same as the 1/3 exponent. All right. Look at number 30. Number 30 says x minus 7 to the 4/3 equals 81. What is the 4/3 exponent? It's the third, wow, that's not what I wanted. It's the third root of the stuff to the 4th. And that equals, and so this is a little this is a little bit strange, but that 4 can go inside or outside. It doesn't, technically it matters, but practically it doesn't matter. So you can put that 4 on the inside or the outside. How would you solve this? Somebody's calling me. How would you solve this? Well, how do you undo a 4th power? 4th root. Do I need a plus or minus? Yes. 4th root you do. So we get the 3rd root of x minus 7 equals plus or minus 3. Sorry. So the 4th root cancels the 4th power. And 81 is made up of 3 4s, or 4 3s. Now what should I do? Raise it to the 3rd. So x minus 7 equals plus or minus 27. Then you would add 7 to each of them. 34 and negative 20. You guys okay with that? Or if it's my wife. Oh, nope. Go away. Do you guys understand that? You can handle that one? Okay. We will see. Okay. Look at number 32. 32 says x equals the square root of 56 minus x. Does this have a solution? I hear yes. I see somebody shaking their head no. You're both right. The answer is maybe. Right? It depends on what x is. What if x is 7? Does it work? Yes. What if x is -2? No. So, whatever happens, this number must be 0 or greater, or it's not a solution. So, we're just going to solve it, look at our answer, and then decide, does the answer work or not? So, we square both sides, and I get x squared equals 56 minus x. What should I do here? Why? This is a quadratic, so I actually want to move everything to the left side. X squared plus x, that's a good x, minus 56. How does that factor? X plus 8, x minus 7. So my roots are -8 and 7. So I look back at the original problem. Do any of those create issues? Yes. The -8 gets thrown out. And the answer is just 7. Okay? Okay, look at number 42. 42 says 5x minus 10 times the square root of x plus 2 equals -10. Does this have a solution? I don't know. That one's kind of complicated. So let's simplify it down, see what we come up with, and then solve it, and we'll just have to figure out if our answer works or not. What should I do first? Move the 5x to the other side. What's that? I would probably move this. Why do you think I would prefer to move that? The 10s wouldn't go away. I don't like negative numbers. So if I move the 5x to the right side, everything is negative on both sides. If I move stuff the other direction, everything is positive. So I will move the 10 over here, and I will move all of this stuff over there with addition. 5x plus 10 equals 10 times the square root of x plus 2. Everybody follow that? Now what? I could divide by 10, and it'll totally work. I'm a little bit hesitant to divide by 10. Why might I be hesitant? I will have 1/2 x. And we're not very good at factoring when the coefficients are fractions. So maybe I'll divide by a different number. I'm going to divide by 5. That will simplify everything, and I won't have any fractions. Do I need to divide that stuff by 10? By 5? No, it's part of this. That gives me x plus 2 equals 2 square root of x plus 2. Now what? Well, I don't want to divide by 2 for obvious reasons. I'm just going to go ahead and square it. I would like to get rid of the 2, but by moving the 2 I will create fractions, so I will avoid that. The next step is to get rid of the square root. So I square this side, and that's pretty easy. That is 4 times, that cancels, x plus 2. Everybody follow that? what happens on the other side? So I get x squared, and then I get 2 copies of 2x plus 4x plus 4. Hey, did you come to teach us? No. So, do you guys know how to square binomials in your head? Remember when we did completing the square? This is just like completing the square only backwards. We're uncompleting the square. So we get 2 copies of 2x, obviously the x squared, and then the 2 squared. Okay? Now what? I see x squared, which makes me think quadratic, which makes me think factor. In order to factor, everything has to be on the same side. We should distribute this, 4x plus 8, move that stuff over here, x squared, those go away, minus 4. That factors into conjugates, x minus 2, x plus 2. So my roots are x equals plus or minus 2. Do those work? I don't know. We're going to have to go back to the beginning and look. Because the original equation was kind of messy, so it's hard to tell. So let's test plus or minus 2. Okay. We stick in 2. 5 times 2 is 10 minus 10 times the square root of 2 plus 2 is 4. So that's the square root of 4 is 2. Is 10 minus 10 times 2 equal to negative 10? Maybe we should write that out. So 10 minus 10 times 2, does that equal negative 10? Yes. So x equals 2 is a valid solution. Let's try, not to break that, let's try negative 2. 5 times negative 2 is negative 10 minus 10 times the square root of negative 2 plus 2 is 0. Is that true? Is negative 10 minus 10 times 0 equal to negative 10? Yes. So it worked. Okay? That one going to confuse you? So our steps were, we got the square root by itself, moved everything else to the other side, we squared both sides. Once we squared both sides, we had a quadratic. We simplified everything to on the right side, brought everything over, took our quadratic, factored it. With the factors, we created the roots. And then this equation is so messy, there's no easy way to look at it and say this number will work, this number won't work. So we just plugged them in to see which one worked, and they ended up both working. Okay, there's really only one more type, and lucky you, it's harder than the rest. Oh no, there are 2 more types, sorry. But one of them's really easy. Yeah? Yeah, that'll work if you want. The trouble with that is if the denominator, so he asked on number 27, there's a 5/3 exponent. Can you just put 3/5 exponent on the other side? And the answer is yeah, it works. The trouble with that is sometimes it doesn't simplify. So 32 does have a 3/5, which is nice. So sometimes it doesn't simplify. Also, if the denominator is even, then you have to remember to do plus or minus. So if it was like 3/2, and then you raise the other one to the 2/3, you would need to put plus or minus on the other side. But yeah, that will work. Yeah, if anytime the denominator is even and you do the reciprocal on the other side, you need to remember to do plus or minus. Okay, I don't see any of these, but it's good to know. What if I had the square root of 2x minus 1 equals the square root of 3x plus 5? How would you solve that? You just square both sides. Or, if you have a square root equals a square root, then the stuff in the inside must be equal. You just drop the square root. Do we need to worry about extraneous solutions? The solutions that look correct, but when you plug them in, they don't work. And the answer is no, because there's no way to make the square root equal a negative number. It's positive on both sides. So I don't see any of those in your assignment, but you might run into something like that. Okay, now for the hard ones. What would be a good one? 52. The square root of 2 minus x plus the square root of 6 minus 5x equals 6. Okay. Don't let me outrun you on this one. Each step is very simple, but it's a long process to get all the way to the end. What would you recommend? Square root plus square root equals 6. We need to square everything to get rid of square roots. Okay? Don't write this down. If I square it in its current form, then the right side is going to be 36. What will the left side be? Well, it will be this times itself, which is 2 minus x. And then on the other end, I'm going to get this times itself, which is 6 minus 5x. And those are really nice. What's going to happen in the middle? I'm going to get 2 copies of the square root of this times that. So it would be 2 square root of 2 minus x and 6 minus 5x. And that's going to turn into a quadratic. And that will work. But nobody does it that way because it takes more time. It's harder. So let's back up. Don't you wish you guys could do this on your paper? All right. That didn't work. I mean, it will work, but it makes things really messy when we don't want to do it, especially because we're going to get the square root of a quadratic equals a quadratic, and then we have to square both sides, so you end up squaring a quadratic, which is a mess. Yeah, not fun. What else could we do? Yeah, we need to get rid of both square roots, but when we try to get rid of them together, we actually make things a little bit worse. So instead, we need to isolate one of them, square it, simplify everything down, isolate the other one, and square that and simplify everything down. And it really doesn't matter which is which. I prefer to avoid negatives, but in this case, you don't have a choice. Whichever one you move to the other side is going to end up being negative. So we'll just move this one. And we get the square root of 2 minus x is equal to 6 minus the square root of 6 minus 5x. Everybody understand why I did that? I've determined I want to get rid of this square root to start. So I square both sides, and the left side becomes 2 minus x, and the right side is a little bit messy. The first term is 36, and the last term is 6 minus 5x. Everybody understand that? Any square root times itself, even if it's negative, just cancels the square root, and you're left with the stuff on the inside. What happens in the middle? Well, I multiply those together, and I multiply those together, so I get 2 copies of, it's actually going to be negative. So negative what? So 6 times this is 6 root 6 minus 5x, negative. And then when I do this way, I get the same thing. So negative 12 square root of 6 minus 5x. Oh, that wasn't any fun. Now what? Well, I still have a square root. I need to get rid of that square root by squaring it. But in order to do that, we need to move everything else out of the way. So those two make 42. So I will subtract 42. And then I'll also add 5x. So 4x minus 40 equals negative 12 times the square root of 6 minus 5x. Can I simplify it further? Yes. Should I divide by 12? No. Why not? That will give me a fraction. Will it still work? Yes, but it'll make things more difficult. Is there a factor I can divide by that won't give me fractions? 4. So divide by 4. Should it be a negative 4? We could do negative 4, and then we would have a positive number on the right side, and the negatives and positives on the left would flip. But we're going to square this in a minute, and anytime you square something, it kills the negatives anyways. So I'm not going to worry about dividing by negative 4. X minus 10 equals negative 3 times the square root of 6 minus 5x. Now what? Square both sides. We should be getting good at this in our head. The left side will be x squared minus 2 copies of 10x, which is 20x, plus 100 is equal to, square this, 9, and then this cancels that. So 6 minus 5x. Everybody follow? Multiply that in. 54 minus 45x. Bring those into the quadratic. Plus 45x minus 54. X squared equals 25x. Oops. Not equals, x squared plus 25x plus 46. Did I do that right? Yeah, I did. Two numbers that multiply to be 46 and add to be 25. 23 and 2. So, x equals negative 23 and negative 2. So, are those going to work? I don't know. We got to go back to the original problem to see. All right. Let's plug in. So, our options are negative 2 and 23. So I put a negative 2 in here, and I get 4. Square root of 4 is 2. Plus 6 minus 10 is, 6 plus 10 is 16. The square root of 16 is 4. Did that work? Yes, it worked. So negative 2 is a valid solution. All right, negative 23. 2 plus 23 is the square root of 25, which is 5. Negative 5 times negative 23 is going to be 50, 65. No, sorry, that's 100. 115 plus 6 is 121. The square root of 121 is 11. is 5 plus 11 equal to 6? No. So that one didn't work. 5 minus 11 would be negative 6, but they're both positive, so no, that one didn't work. Okay. Do you want to see another one of those? Yes? Okay. So read off 54 to me. What does 54 say? Square root of? Okay. Got to get one of the square roots by itself. So the square root of 5 minus x equals 4 minus the square root of 3x plus 1. Square both sides. 5 minus x equals, the first term is 16, the last term is 3x plus 1. The in-between terms is just two copies of that. So negative 8 root 3x plus 1. Everybody good? Okay. Those make 17. So subtract 17 and subtract 3x. So negative 4x minus 12 equals negative 8 root 3x plus 1. What should I do here? Divide by negative 4. That will get rid of all the negatives. So divide everything by negative 4. X plus 3 equals 2 root 3x plus 1. Square both sides. X squared plus 6x plus 9 equals 4 times 3x plus 1. You follow? That makes 12x plus 4. Subtract 12x, subtract 4, x squared minus 6x minus 5 plus 5, which factors into x minus 5 and x minus 1. So my roots are 5 and 1. And we plug those back in to see if they work. If one works, does that mean the other one doesn't work? No. They might both work. They might both not work. You might have one of each. So let's try, were they positive or negative? Positive. So 5 and 1. If I plug in 1, I get root 4 plus root 4. Is root 4 plus root 4 equal to 4? Yes. So 1 works. I plug in 5, and I get root 0 plus 15 plus 1 is root 16. Yes. So in that case, they both work. Okay. The only other type would be like number 60, and it looks harder than it is. So the square root of 2 minus root x equals root x. What should we do? Square both sides. So 2 minus root x equals x. Now isolate this root. I'm going to move it over there to avoid the negative. Move that over there. 2 minus x equals root x. Square both sides and then solve it. So that one looks complicated, but it actually isn't. All right. How far are you supposed to go? Okay. All right. Get to work.